to solve a polynomial inequality, we move everything to one side of the inequality. So if I move everything here to the left side, I have, I'll add x. So I've got 2x squared plus x, and then subtract 3. That's less than or equal to 0. The next thing is to factor this as much as possible. So we can factor this as a 2x and an x, and then we're going to have a 3 and a 1. So minus 1 there and a plus 3 there. And this is less than or equal to 0. Now, this gives us our zeros of this polynomial. We get, for the first one, if we subtract 3 and divide by 2, we get x equals negative 3 halves. And for this second one, we have x equals 1. So these two numbers, we're going to go ahead and plot those on a number line. We've got negative 3 halves, and we've got 1. And we know that at each of these places, the polynomial is equal to 0. And then we know that the intervals that it creates, it will always be positive or always be negative on each of those intervals. So we're going to choose some test points here. I'm going to pick just one test point over here on the far left, and then show you a little trick on how to not have to do more. Over here, I'll plug in x equals negative 2. Okay, negative 2 is less than negative 3 halves. And if we plug negative 2 into this polynomial here, we would get a negative 4 plus 3, so negative 1, times a negative 3, which is a positive number. So positive. Now what's really nice is that if I think about moving across this 0, okay, all I actually need to know is the multiplicity of that 0, because I know in the graph of a polynomial, okay, if I have an odd multiplicity, I actually cross through the axis. And if I have an even multiplicity, I just touch the axis and bounce back. So, looking at negative 3 halves, that came from this factor of 2x plus 3. And the exponent on that is 1, which is odd. And an odd multiplicity means that I'm going to change signs as I pass through that 0. So I move from positive to negative. And then, as I'm at negative, I cross at 1, and x equals 1. That has a multiplicity of 1, which is odd. And again, an odd multiplicity means that as I hit that 0, I cross through the axis. So again, it changes from negative to positive. So that's a quick way to get the signs of these intervals without actually having to use a test point on every interval. You could just pick one, and then you can go through and get the others. So now that I have my signs, I look here and I want my polynomial here has to be less than or equal to 0, meaning I want negative values. So I see negative values here between negative 3 halves and 1. So my solution is from negative 3 halves to 1. And because this is less than or equal to 0, I include the equals 0, meaning I include these zeros here. So I'll include negative 3 halves and I'll include 1. So brackets in my interval notation to indicate that those are included in the solution. For this second one here, again, we move everything to one side of the equation. So if I subtract 2x from both sides, I have x squared minus 2x plus 1 less than or equal to 0. Then we factor. And this factors as x minus 1 squared. So this gives me a 0 of x equals 1. And notice the multiplicity of that is 2. So I can plot a number line, plot 1, and pick a test point. Okay? If I plug, say, x equals 0 in, to this I get 0 minus 1 is negative 1, squared is positive 1. So it's positive here. And as I cross this at 1, that has a multiplicity of 2, which is even. And an even multiplicity means that I just touch the axis and then bounce back. So it's positive on the left and it doesn't change. It's going to be positive on the right. Now, we are looking for when our polynomial is less than or equal to 0. It's never less than 0 because it's always positive on these intervals. Okay? However, it is equal to 0 right at 1. Okay, so our solution to this inequality is just a single value of x equals 1. Okay, that's the solution. If you wanted to write that in interval notation, this is kind of a strange thing, but when you have a single number in interval notation, we actually write it in little curly brackets. Okay, and that's the interval notation for just a single number.